Welcome to this online tutorial. Welcome to this online tutorial about integration. So generally today we are going to discuss about integration, and our area of concern is going to be the tan substitution. So we are going to see how to employ tan substitution when integrating certain functions. The tan substitution is basically applied when evaluating integrals of the form. So it is applied, this is applied in integrals of the nature, applied in integrals of the form, integrals of the form 1 out of a squared plus b squared x squared changing x. So for tan substitution, we apply tan substitution for integrals of this kind. Given an integral which is in this form, then we employ tan substitution. For example, if I'm having the integration of 1 out of 1 plus x squared changing x. So to evaluate such an integral, you need to employ tan substitution. A squared is 1, so this is a squared. Then b squared, as you see, b squared is the coefficient of x squared. So for this case, b squared is a silent 1, which is there. And x squared is that. Another example, this integral 1 out of 3 plus 5 x squared changing x. To evaluate this integral, you also need tan substitution, whereby your a squared is this first term of the denominator, which is 3. So that is a squared. Then b squared is this 5, and x squared is that. Another example, we have an integral of this form 1 over So for this integral, you also need tan substitution. You need tan substitution to evaluate that integral. A squared is 5, a squared is 5, b squared is 9, b squared is 9. Then x squared, this term here is standing for capital X. X plus 2 is representing capital X. You can let it be capital X. So if this whole term here, x plus 2, is standing for capital X, then we shall have capital X squared. So this integral is also in this form. To evaluate that integral, you need to employ tan substitution. So how can we apply tan substitution? That is the fundamental question. We are going to see how to apply tan substitution. So we are going to consider an integral. We are going to consider our general form. Consider the integration of 1 over a squared plus b squared x squared changing x. So you let, to apply tan substitution, you will let in this way. So you can let b squared, you let this term here, let b squared, x squared, b s squared multiplied with tan squared theta. So you use this substitution. Let the term here be the term here multiplied with tan squared. For example, if I'm having the integration, of 1 over 3 plus 5x squared dx. So here you will have to let the term here, which is 5x squared, 5x squared, let 5x squared be the term here, be the term there, which is 3. Let 5x squared equal to 3 multiplied with tan squared theta. Tan squared theta. So that is how we let. Another scenario, if I'm having 1 over 1 plus x squared changing x. So how do you let here? You will let the term here, which is x squared, be the term here, which is 1 multiplied with tan squared theta. Multiplied with tan squared theta. Then for this case here, for that case there, you will have, for this integral, you will have to let a term there, which is x plus 2 squared. Let that term, sorry, there is a 9 here. You will have to let 9, let the term here, 9 multiplied with x plus 2, the whole bracket squared, let that be equal to 5 multiplied with tan squared theta. Basically, that is how we use that substitution. Now let's go back to our required integral. So we want to evaluate this. I've said you let the term here be the term here multiplied with tan squared theta. After that, you apply square root on both sides. Apply square root on both sides. So we shall have square root b squared x squared. This is equal to square root a squared tan squared theta. Now when you take the square root on both sides, this one will go out with that, also this will go out with that. So this side we shall have bx. This is equal to, also here when you take the square root, we shall have a tan theta. So basically that is what we are having. So after that, now we want to change our variable from x to another variable theta. We want to change our variable from x to another variable theta. So we want to change x to theta. That means we shall also need to change this dx. So differentiate on both sides. So if I differentiate dx this side, b is a constant. A and b, both of them are constants. So if I differentiate bx this side, differentiate bx, I will get b is a constant. I will get b. So this b is differentiated with respect to x. This is equal to, also differentiate this side. I will get a sec squared theta differentiated with respect to theta. When you differentiate tan, you get sec squared. When you differentiate tan, you get sec squared. So this side I will have a sec squared theta, but differentiated with respect to theta. Now make dx the subject. Divide both sides by b. So I will have dx as a over b sec squared theta changing theta. So that is my dx. Now we are going to go back to our required integral. We are going to go back to our required integral.